Okay, so let's just summarize. Just want to make sure it's a little bit different of material than we've been doing with all these integration techniques. So when you see the words converge or diverge, if convergent, evaluate, you know you're going to be finding the limit of an integral. So you're ready to write a lot, right? You've got to take a lot of steps to rewrite it with a limit. If you have a horizontal asymptote, there's going to be an infinity or a negative infinity, because I should have said that, a plus or a minus infinity in one or both of the limits of integration, right? So here I have an infinity, here I've got infinity and negative infinity, right? So I guess I didn't give you an example of just one with a negative infinity. Oh, here you go, or just this, right? So these are the three things. So you have a positive infinity in your limit of integration, a negative infinity in your limit of integration, or you have both. And you have to go do them separately, so you've got two integrals on deck. Okay, so always the first step is to rewrite it as a limit and put the t where the infinity was. Rewrite it as a limit and put the t where the negative infinity was. And this one here, negative infinity and infinity, you must break it up at some number. You can choose to do any number. 0 is usually a nice one. And then do them separately, right? Go figure out what this one is separately and rewriting this with a limit, right? And putting the t where the infinity was. And then this one here, I would rewrite put the t where the infinity was and go do this integral. Okay, so that's when I have a horizontal asymptote. When you'll be looking at a vertical asymptote is when you'll get this in these instructions, converge or diverge, if convergent, evaluate, and you look at it and you see no infinities. Then get curious, where is my vertical asymptote? Where is the denominator 0? This one, the denominator is 0 at 4, right? So the denominator is 0 at 4, so that means I'm going to replace 4 with a t and take the limit as t goes towards 4. I guess I forgot the positive or negative, right? So if I'm going from 1 until 4, I'm coming from the negative side. All right, so this one here, I've got looking at this, converge or diverge, no infinity. So I'm thinking about where is that vertical asymptote? Well, it's got to be back here at -2, right? That makes the denominator 0. So I'm coming towards -2 from the positive side. So I should have a positive there. So then you would go forward and put the t in for where the -2 is and go forward with doing the integral. Okay, this one I didn't make an example of, but let's finish it, but let's look at it. From -8 to 8 of this. Does -8 make the denominator 0? It does not. Does 8 make the denominator 0? It does not. Where does this have a vertical asymptote? At x equals 0. And if I'm looking in the interval between -8 and 8, isn't 0 in there? It is. So it's necessary to break it up at 0, where the vertical asymptote is, and then it's necessary to do both of these integrals separately. So this one here, from -8 to 0, put the t in for the 0. And if I'm going from -8 to 0, I'd be coming from the negative side. And then to this one, 0 to 8, I'd put the t in for the 0, and I'd be taking the interval between 0 and 8, and I'd be coming from the positive side.